In this video I will try to discuss what is internal reaction, or different types of internal reaction that may come inside a beam. Say let us see, this is our beam. It has two support, one is hinge, one is pin, and say it has different types of load. Say one load here, one load here, some uniformly distributed load here, etc. etc. whatever it is. Now, what is happening here? This beam is supported by two supports and it has many loads. So these supports are restraining the beam against this load. That means this load will try to move the beam and this support will hold it in place. So that is the purpose of this support. But inside this material, some different types of reactions also develop. Inside them, say here, inside the material also, and broadly three types of internal reaction develops. So first, one is shear force, and second is normal force, and third is bending moment. Now I will explain what are these. What is shear force? So shear force means the reaction that is developed perpendicular. So this is my beam. The shear force that is developed transverse to the lateral to the beam or perpendicular to the beam. Say this is my beam. It is single beam. Consider support here, support here. So if my beam tends to move this way, one part will remain here, other part will go this way. That kind of movement is called shear movement. The force, internal force, which causes this is called shear force. So it is transverse. Other kind of force is normal. That means if I apply different kinds of load on my beam, if my beam tends to expand or contract, that means some kind of internal force in axial direction occurs. That is called normal force. Other kind of force is not actually force. Other kind of reaction is called bending moment. This bending moment causes the bending. Like if my beam is this, it will cause this kind of bending or upward this kind of bending, depending on load. These three types of internal reactions might occur. Say we are considering this point. So if I draw the free body diagram of this portion, say this, my reaction here is this. So normal force will occur in axial direction, either this way or this way. This means tension at this point. If it is this way, it will mean compression. So initially we assume tension for everything. We assume tension. After analysis, if we find it is negative, that means compression. Then shear force. Shear force we assume this way is positive. Now what does this mean? This means that this section will remain here. So this will remain here. The other part of the beam will move down. So this assumption we consider positive. That means this part will stay here, other part will go down this way. Then we call it positive. Other kind of reaction is moment. And moment we consider counterclockwise. It means the beam will bend this way. If beam bends downward, we consider it as positive moment. Now, so at this point, three internal reaction. So we consider left part. Can we consider right part? Yes, no problem. So if we consider right part, say I am drawing here. So this is my beam. Oh, I forgot my load here. It should be here, somewhere here. So it has load here. It has a inclined load here. Then what I will do this time, normal force I will draw this way, shear force I will draw opposite way. This is shear force, this is normal force, and moment I will draw this way. So if we consider left side, this is our sign convention, and all these are positive. If we consider right side, this is our sign convention. Okay, let me make it bigger, it's become so messy. Okay, say this side is this side. So this is my shear force, this is normal force, and this is my moment. If we consider right side, this is my normal force, this is my shear force, and this is my moment. So we can consider either left side or right side, whatever side, both are okay. As I told you before, in mechanics, whatever method you follow, whatever side you consider, your answer must be same. So don't worry, take the side whichever is easier to you.